So here comes a short solution to these intermediate exercises. So it's very important that you actually try to come up with the solution yourself before, because only then the exercises actually make sense. Now, first thing is here are actually asked to use a particular helper function because you want to create a vector with the numbers from -2 to 19 with a step size of 0.5. We can do this using our function sec. We start with our keyword from -2, and 2 equals to 19. And the step size is 0.75. If we execute this, we actually get the desired vector. Note that you actually can skip here the explicit names of these arguments, because these are the default arguments to be used by the function. But sometimes it's useful to be a little bit more explicit. Now we should actually give this vector a name, because we need to reuse it here in the second task, where we should create an index vector. And we can do this again with the function sec and use the along with keyword. And here just add the name of our initial vector. And if we execute this, look at the vector down here, we see that we now get an index vector, meaning a vector that contains the numbers from 1 to the length of the original vector, with a sequential numbering from integers. So that's useful, especially when we're using iteration concepts like for loops later on. Now here we are actually asked to apply the concept of vectorization to our vector 1 here. And we are asked to compute the log of each of the elements. Now we could call the function log to each element of the vector, like for instance to compute the 5th element of the vector, or the say 8th element of this vector. We could use the indexing operation we learned about before, but we could also vectorize this operation by simply calling the function on the entire vector, and then we actually get the logarithm of each of the elements. Now, what might maybe draws your attention here is the warning message that NaNs were produced. So for the first 3 elements of the vector, we see something strange here, the so-called NaN. If we look at the vector again, and then we see that the first 3 elements are negative values. We can actually have a look at the first 3 elements by using column 3 here. That's a nice way of indexing subsets of vector. And we see that these are all 3 negative values. And you might remember that the operation of taking a logarithm is not defined for negative values. If you try to compute the logarithm of a negative value, you get something called an NaN. That is not a number. And R produces this whenever a certain mathematical operation is not defined. And the final task is what happens if you concatenate vectors of different types using C. We could think of a vector containing only characters, say a vector containing the elements hello and bye, and a second vector containing, say, doubles, containing the elements 2.6 and 9. And then we could think of a vector that contains logicals, which simply contains twice the element 2. Now, if we concatenate the character vector and the doubles vector, what would you expect we get? So we should write the name of the vector correctly. You now see that actually every element of the 2 vector has been transformed to characters. If we concatenate, on the other hand, the vector with the doubles and the vector with the logicals, we see that here everything has been transformed to doubles. And if we concatenate actually all three of these vectors, we see that everything now has been transformed to characters. Now here R uses the same hierarchy of object types that we have encountered before, with character vectors being at the top of a hierarchy, then coming doubles, then coming integers, and then logical values, meaning if you concatenate two vectors of different types, the vector that is at the top of the hierarchy determines the object types of all elements of this hierarchy, exactly for the reasons that we have actually discussed already before.